So, hello everybody. I'm here today to talk about Singular. But before we actually start off, let me quickly introduce myself. My name's Daniel, and I work on the GWT team at Google. And as some of you may know, I'm actually fairly involved in the open source community about GWT. Before I start talking about Singular, I actually want to talk quickly about AngularJS. And this talk's not about fighting with AngularJS. It's more looking at AngularJS from a optimizing perspective and what you could be doing if you have something like the GWT compiler at your disposal. Both GWT and Angular are very sophisticated frameworks, and they both have strong points and they both have weak points. I'm just going to go into some of the weak points and see how we can fix them. Before I do this, let's actually look at the good parts in Angular. Angular got one thing really right, and that is developer productivity. Because in Angular, you don't write much boilerplate. You just express intent. And the framework figures out all the nasty details in between. Angular also does a couple of other things really good. They kind of pioneered a good application structure for JavaScript applications. This whole dependency injection mechanism, kind of a given thing in the Java world, but in JavaScript, they kind of pioneered this thing. And also, they have a really good story on testing. Because of the way an Angular application is structured, you can easily write tests for these kinds of applications. So for the people in the audience who maybe don't know Angular, I'm going to briefly skim over a typical Angular application and what the Angular team normally likes to do. In these kinds of cases, they take a to-do application because it shines, Angular really shines in these small kinds of applications. So bear with me if you already know how this stuff works. So in Angular, you go ahead and you define a function. In this case, my to-do controller. And you inject a variable called scope in there, which is somewhat your model. You can put stuff in there, and that stuff is going to be displayed in the view. And now we can just add stuff to it. We can say, well, there's a variable on the scope called to-dos. And that's an array of to-dos which have a text, and we can track whether they're done or not. And we can add functions to this thing as well. We can say scope add to-do is a function which will add a new to-do onto that list using the scope.form_to-do text. So it's basically reading back a value that originated from the UI. And we can define another method called clearCompleted, which will loop over the to-dos and remove the ones that are already done. The second thing you will need to do in Angular is define a template for this. And the connection between the template and your JavaScript comes from this directive over there, this ng controller. This is what Angular calls directives. You can see it here, to-do controller. We're saying here ng controller, to-do controller. This is how they both link up. And then we're just defining an HTML form. Down here, we're defining an input element. And there's another directive in there, ng model, and it says form to do text. So what this does, it basically does a two-way data binding for the form to do text. So every time I type into that box, form to do text in the scope gets updated. Or if I update form to do text in the scope, this text box will get updated. One line below, we see how you can consume a click event. You define a button and you place a click directive on it, ng-click, and you just say which expression should be called inside of the scope, or add to-do method from the controller. And we can do the same thing for a button that triggers to clear the completed items off the list. Up here, we're going to use something called an ng-repeat. And we're going to say for every to-do in our list of to-dos, emit this piece of HTML. So it's going to loop over the list of to-dos. And it's going to emit a checkbox, which is two-way data bound against the to-do.done Boolean inside of the scope, so it's whether checked or not. And we're going to emit a span with a class on it that's also done-true or false, and we're going to emit the text of that to-do. So if you think about that, this is not a whole lot to write. This is just normal HTML, and you kind of enhance it with these directives. And if you looked at the earlier code inside of that controller, That's very terse. It just does the bare minimum, and this application will just work fine. So what's bad about it? Well, first of all, if you come from a GWT perspective, you're looking at this and thinking, how much work does it need to do? And there are actually multiple problems with performance, even in such a small example. So first of all, it has to scan the whole DOM and find all of these directives to figure out what it needs to do. And it's doing that at runtime. And it's doing that for every user again. And if you think about providing a good user experience, it's not a good idea to shove off that work onto everybody's browser. Another thing you might have heard from in Angular is something called dirty checking. This magic two-way data binding that they do this with so-called dirty checking. So basically, on every change to the model, they have to revisit all of the model and find out what has changed to update the view. And you can imagine the bigger your application becomes, the more expensive this becomes. This is why the Angular team is very clear about that not all applications are a good idea to write in Angular, because there's a certain drop-off point. And my third problem with this is it's not really optimizable by compilers. Because first of all, we don't understand the template at all. We just do it at runtime. And the other thing is, because of how their dependency injection at least works in this example, you can't really obfuscate the tokens. If we name -scope to A, the dependency injection just stops working. Of course, there's ways around that. You can inject this differently in Angular, and it just works. And I'm not saying they're not working on this for Angular 2.x. They're going to solve some of these problems eventually, but they're still there. So looking at this from my perspective, I was thinking, how can we get the good without the bad? So what do we need to do? Well, first of all, we need to parse these templates at compile time and resolve these directives at compile time. Because it's a significant chunk of work that every Angular application has to do on every startup that can be handled up front. Also, to be able to write really big applications, we need to understand the scope sufficient enough so that we do not require dirty checking. Because remember, the bigger the application gets, the more expensive that dirty checking will become. If you don't have it, you don't have a scaling problem. Also, we want to be able to make this as small and terse as possible. And there's one thing, and Ray pointed that out in his earlier presentations, we are really good at that. Most of the time, we're smallest and fastest in class. And that's exactly what Singular is all about, leveraging the compile time optimization of the GWT compiler. So first of all, you can think of Singular as an Angular implementation in Java. And the static typing of Java will help us to understand the scope sufficient enough to not require dirty checking at all. Because we can do both of these things, resolve the templates at compile time and not require dirty checking, we'll actually scale to really big applications and will be running efficiently on mobile. On top of that, just using the Java language on its own will provide us with great tool support across the board. The Java community has built up these really great tools like Eclipse or IntelliJ over the years, and that's something that's just not there, maybe yet, in the JavaScript equivalent. So before I talk any further about this, I actually just want to start showing it to you. So let's switch to demos. So here I have a Singular application. It doesn't contain a whole lot. Right now it's basically an empty template. So we can do the same thing you've just seen in Angular. We can just define a controller in here. And I'm going to use this hello controller that we got in scope here. I can actually make this a little bit bigger. So I'm going to say I want to use that hello controller. And then we go ahead and define a field in here, and we're going to say input type equals text. Oh, whoops. And we're going to do a two-way data binding. It's not going to be ng model like you would expect from Angular, just because this stuff also works with web components, and this ng model doesn't really do the trick. So what we do is we say bind the value of this component against the username that's in scope. The next thing we need is a button. Let's put a text on there. And we want to be able to consume event from this button, so we don't say ng-click, we say on something event. So this will also work with web components that have different kinds of events. We say on click, and we want to call the say hello method from our Java controller. Let's put a vertical line. Oops. And down here, let's just go ahead and emit a greeting back into a text node. So let me show you what the controller looks like. So in this controller, we've defined a scope which contains the username and the greeting. And we have one method in here, the sayHello method, which will read the current username, which is bound to our text box, and write that into the greeting. So we can say something like hello username. So if I open up my browser, and if I compile this, this is how fast this whole process of resolving everything and compiling everything actually is. It's integrated perfectly and super def on what we already have. So if I start typing here and I press the button, you can see it updates down here. So let me actually show you that this is real two-way data binding. So I'm just going to go ahead and emit the username down here. And just because we've bound the username up here, which is actually on a key up, so every time I'm going to type, we're going to update that text node down there as well. So let me go here, recompile the thing. If I start typing here, you can see it updating right away. So I think that's already a cool example that kind of shows that you can do a lot of these things at compile time instead of runtime. But let's take a little bit more of a sophisticated example. Oops. And I don't want to type this out completely, so I'm just going to paste it in and go over it. Oh, didn't it? There it is. So this is basically the to-do example I've showed you earlier, implemented in Angular. And now we're doing it with a Java controller on top of that. So we have the same thing here. We have an input element, which is bound to the form to-do text. The annotations are a little bit different, so they would work with web components. We have a button down here that calls the add-to-do method. We have a button down here that calls the clear-completed method. And up here, we are using an ng-repeat to emit all to-dos inside of the scope. We place a label around this with a changing class. We have a checkbox, which is bound to to-do.done, and we have a text that we emit here. So if I go ahead and pull up Chrome, I'll recompile that, and this is the application. It kind of looks dreadful because there's no CSS, so let me quickly go ahead and add some CSS so it looks a little bit nicer. So if I recompile now, we have a hello, a simple to-do application. So if I go ahead and I put this in here, you can see I'm typing here, and as soon as I press the button, it actually gets added to the list. This causes the list to update. So I can say learn J to Objective-C. And I can also mark things as done. You can see this is actually a two-way data binding updating the DOM here. I didn't write any code to do this. So if I go ahead, mark both of them as done, I'll just hit clear completed, and off they go. So let me show you how that controller actually looks like. So you can kind of get a feeling of how much code you need to write. So first of all, you define the scope. That's a little bit of extra work you have to do in order to get rid of the dirty checking. So you define that scope. It has a list of to-dos, and it has this form, excuse me, and it has this form to-do text. And every to-do has a text and a Boolean. And then you have these two methods. The add-to-do method, which would generate a new to-do, add it into the list using the current value from the input element in the scope. And you have this clear completed method, which loops over the to-dos and will remove the ones that are done. And that's literally all your code you need to write in order to support this. Okay, I have one last example. And you might remember this from last year. Gokduk here in the States gave an excellent presentation on how you can do web components, excuse me, with GWT. And he kind of introduced JS Interop at that time. But let me show you how you can use web components with Singular. So what we're going to do is we're going to have a controller up here, which we coincidentally are going to call Polymer controller because these are Polymer components. And down here, we're going to use a Google Map web component. And that center marker, this red thing that drops down on the map, we bind this to the marker property in scope. Forget about the CSS, this is just to make the demo fit on screen. And then we have a paper toggle button, and we bind the checked attribute of this thing to the marker if it fires a change event. If I show you the Polymer controller, all this is doing is just defining that scope. There's literally no code here. Keep that in mind. Let's move the CSS out and compile this. So what you're seeing here is Google Map on top and the paper toggle button down here. Keep in mind, I've not written any code for this. This is just two-way data binding. So as soon as I click here, you can see the center marker being updated on the map. So let me get back to slides for now. So looking at these demos, if you implement the same demos using Angular, we haven't optimized for this yet. Just because we use a toolchain that already optimizes, we already come out 4x smaller. We come out way faster in initial rendering, and we come out way faster in runtime performance. Remember, we do the work up front. But there's actually more. And before I actually go into this, I quickly want to talk about application structure. And you guys know about all these kinds of things like MVC, and you have model, views, and controllers, and there's different patterns of arranging them in different ways. And in the GWT world, we've kind of been pitching MVP in a way which basically works like this. You have a presentation state, you model somewhere, and you write some rendering logic that will put this into the view somehow. And then this screen basically fires some events. There's a controller that consumes these events and updates the model, and off you go in a circle. And you kind of write this bit, and this bit. If you look at Angular, they have almost the same thing. They have model, controllers, and views. But what they do is they arrange the thing a little bit different. So they have their controller up there, which only speaks to the model, and it can't really speak to the view. And the view is actually all of this, the event handling logic and the rendering logic, as well as the screen. And you only write this controller, and you define the model a little bit using the scope. And the rest of this is just a configuration through directives. So all the event handling you've seen, something like onClick, is just configuring a view. Or the rendering logic, like saying, oh, I need to output this thing, is basically a double mustache, or bind this value into this component. And if you think about this, because this write bit is so easy to write, it actually yields a sweet spot for cross-platform applications. Because what you can do, you can use a different templating format for different platforms. I've just showed you one, HTML for the web. But for Android, you can actually use their normal XML files, their normal widgets, and bind them against the controller. And you can do the same thing for iOS. This means that you'll be able to customize on a per-platform basis, where you need to customize because you need to get UIs right on a per-platform basis. And you get that freedom to change the UI on a per-platform basis, while still being able to share vast amount of code that actually get the data from somewhere, from your server, from storage locally, and push that into the models. And this means that you can actually keep your application's logic in sync. The only thing we need to give you guys, if you want to do this, we need to provide an easy way to break out of this paradigm. So you're not caught in something. If it doesn't fit for a certain part of your application, you need to be able to just do it the native way. Let me show you a demo of this. So remember my earlier demo when we had, let me quickly paste that in, when we had this example up here. Sorry, wrong file. So we had an input element, bound to the username. We had a button bound to the say hello method, and we updated the greeting in scope once we clicked that button. So I can do the same thing for Android, just using an Android layout file. It's an XML file format. And you can see we're just using native Android widgets here. So we're having a linear layout. On top of that, we're having another linear layout, which you can, as a web developer, think of as a div, which you can configure on how it's supposed to render. And if you look in here, here's a directive in here. It says tools, ng controller, use the hello controller for this bit of your application. Down here, we have an edit text, which is kind of an equivalent to an input type on the web. And we're saying, please bind the text of this thing. Notice it's not bind value here, because it's going to be the set text method that's actually doing the work here. Down here, we have the button that says on click, call the say hello method of the controller in scope. And down here, we emit the greeting. So let me actually show you that application running. So the native bit, I'm actually building that with Android because I don't want to recommend you just doing everything cross-platform. The last bit, having that activity and actually stuffing that UI in, that's just going to be native work. So I'm doing this with Android Studio here. So let me see. Up we are. So if I go ahead, how am I supposed to get down there? If I type in here, and I press the button, you can see the same application logic being applied to Android. Who thinks that's cool? But I can do one better. I just have to find a way of actually getting down to the lowest end of that emulator because I need to be able to press the home button. Anybody got any good ideas? I didn't get that.
Go to the upper Apple menu, just turn dock hiding on. Left, right there, dock, turn hiding.
Thank you. So remember we had a second example. We had a map on top, and we had a button to switch that map back and forth using web components. So as it turns out, Google has this really cool project called Polymer, which gives you these kinds of components on the web called web components. But we also have these kinds of components for Android. Material design widgets. So we can also be using these as well. So I have an application here. You can see there's a Google map in here. Hopefully the Wi-Fi is really spotty. Hopefully this actually loads up. And I can do the same thing here. If I use this switch, you can see I can toggle that center marker as well. I'm completely free to relay out this however I need this on a per platform basis. But still, that code that actually does the updating, it's actually done inside of the controller. So let's get back to slides. So you've just seen Singular running on Android. And you can think with Tom's presentation about J2 Objective-C, of course, you can feed this through a compiler and make it run on iOS just fine. But the other thing you will need is cross-platform APIs. If you want to make an HTTP call from your controller, you will be doing this differently on Android, iOS, and the web. And therefore, you would need something like an HTTP interface, and you would need an implementation that works on the web, on Android, and on iOS. And you would need something like dependency injection to wire the whole thing up, which might sound complicated at first. But it's actually not a whole lot of APIs that you need. You need something like HTTP sockets, you need storage and the file system, you need things like location, camera, and the media, notification, and status, which is a lot of work to do. But there's already existing work. There's already people who have done all of this work. This project is called PhoneGap. And for the people in the room that don't know PhoneGap, PhoneGap is basically a JavaScript API to enable you to write cross-platform applications in JavaScript that run inside of a web view on different devices, and that have a consistent API for exactly all these things that we need. We're not interested in the JavaScript API because we want to be running Objective-C, Java, or JavaScript. But we're interested in a consistent API. And we already have this implementation for Android and for iOS. And in the GWT SDK, we already own it for Java. So the only thing we're left to do is actually providing a little bit of plumbing. The other thing you need to be able, if you have a cross-platform SDK, you need to be able to break out. If there's something specific to Android or iOS, or it's specific, let's say, to an iPad, the framework should not hinder you to do these things. To give you an idea of how this actually works, I have a couple of slides with code. So in here, we're defining a Java interface called Hello App. That's what I've been using for these demos. And it extends a certain base interface called ngBinder, and in this case, it's typed with element. You can kind of guess why there's a certain type involved, because this needs to be DOM element for the web. It needs to be Android View for Android. It needs to be an Objective-C type in here. And through this annotation up there, saying, well, the template is hello HTML. This is basically how you bring your code and your templates together. And this basically kicks off a generation process which will generate an implementation of exactly that interface. And you can see this down here. This interface, this class, you can just instantiate that class, say hello app binder, and this implements exactly the interface you've defined in the first place, ngBinder element. And it only has one method, start. And you can give it any parent of your application. So this means you can use any node within your existing GWT applications to start this thing in. And if you call start, you're getting back a registration. Pretty similar to a handler registration in GWT. And if you call cancel on this thing, it just blows the whole application away. So you're in control of how much and how big you want to make these parts inside of your application. How would this look for Android? Well, you do the same thing, but you extend now ngBinder view. And in this side of this annotation, you just say, please generate an Android implementation of this interface. And use the hello.xml instead of the hello.html file. How would you use something like this? We don't want to be too opinionated about it, but this is one way you can do it. So you have your normal activity, and I've partially shown you that in Android Studio. What you do is you set your normal view, and you grab out a certain widget from that view. In this case, I've just chosen to use a linear layout, but just because it has an add view method, so I can add something to it. That's the only requirement, actually. Then you instantiate that particular binder, and on Android, you actually need to give it access to the base context so it will actually work. So this is why we require something in the constructor. But from here on out, it's just an ngBinder view. You call start on it, and if you need to cancel the thing, you just get the registration back. So these two interfaces are actually everything you need to connect with. The ngBinder with the start method, you'd get back this registration, you call cancel on it, and it just kills the whole thing. So this means using this inside of an existing GWT app is tremendously easy. You just pass in the parent. But what if you want to be able to use this as a new application, but some certain part of the application you don't want to do this way? Well, you can go ahead and mark a certain node in your templates as external. From this point on out, the framework will just ignore everything below there. But you can mark certain events that you need in order to work. Let's say you want to draw a chart or something like that. You might want to do this with this framework because you already have a good charting library to do it. You would mark a certain div or any other DOM element in your tree as external. And from there on out, you would mark the events that we need to give you, something like, oh, this node is now showing or this node is now hiding. And you would know what to do. The other thing that gets real easy with this is testing. Think about this structure. You write the controller and you define the model. But both of these are pure Java. So that means no more nasty GWT test case, which we first have to compile and run inside of a browser. It also means no more special mocking solutions, because any normal Java framework that can do mocking will just work for these kinds of things. Let me give you one example. Let's say we want to test the add-to-do method from our to-do controller. So what we do is we build an instance of the scope, and then we pass that instance into the controller. And then we can assert that he added two things into that scope, learn singular and build an application. Then we can modify the scope and say, well, someone typed in foobar into that input field. We call the add-to-do method. We can assert that these are now three things inside of that list. So you can see these tests are really easy to write, really easy to maintain. They will run really fast. So let me sum this up. We started off with AngularJS, and I particularly want to make this clear. This talk is not about telling you that Angular is a bad idea, because frankly, it's not. It got a lot of good ideas in there. And one of the major ideas is especially developer productivity, and I think you've just seen that. Their story for testing is really great. But I think for big applications, they punted on one particular really important thing, and that is performance. Performance is critical to these applications, because if there's a certain drop-off curve from where your application won't work anymore, you're bound to hit it sometime in the future if your application is successful. So if we build something, we don't want to provide you with something that's going to fall over at some point. Maybe you run lucky and you won't fall over. Maybe you don't. For me, that's too risky. And that's exactly what Singular tries to be, an Angular implementation in Java that doesn't do any dirty checking and does most of the work up front, and thus will actually scale to really big applications and run efficiently on mobile, which in these demos is already 4x smaller. It's much faster on initial rendering and on runtime. And since the way of structuring code in this way, where you write application logic, you define scopes, and you just define templates with directives, makes it real easy to swap these out for different platforms. It actually yields us a sweet spot and the freedom we need to write cross-platform applications. So you kind of give people the freedom to mess around with their UIs as much as they need to, using native tools, using native designers, but still share all the code that you want to share. I've shown you running it on Android. I'm soon going to show you actually running it on iOS. There's a couple of nifty details we have to sort out. Let me say thank you, and I'm really happy to take any questions.